Okay, hopefully you've included this table in your notes. We're going to use this to work the example. You'll need to make sure you put the example in your notes. We're going to go ahead and work on finding the algebraic expression or the rule for this sequence. The first thing we always want to do is to look at our terms and determine the growth between the terms. What kind of growth do you see going from 3 to 6, from 6 to 9, from 9 to 12? Well, hopefully you see that they're all increasing by 3. Each term increases by 3 to get the next term. That is our growth. Or you could call it the change in y, or you may hear it called the rate of change. That all means the same thing, that it's the growth. As you'll notice, they each increase by 3. Because they all increase by 3, that's called a constant change. It means it will always increase by 3. Never anything else. It's constant. And because it's constant, it becomes our scale factor to the n, meaning that we multiply the position number by this 3, and it will give us the value of our term. So if we multiply the 3 times position 1, 3 times 1 is 3. That's the value of our term. If we multiply 3 times the 2 position, 3 times 2 is 6. If we multiply 3 times the third position, 3 times 3 is 9. If we multiply 3 times the fourth position, 3 times 4 is 12. What do you think is going to happen when we multiply 3 times n? Well, we get what we call 3n, which means 3 times n. So this is going to be our algebraic expression or our rule. We can multiply 3 times any position and it will give us the value of our term for the sequence. I want to stop for a second and talk about 3n. Do you remember when we were talking about the different ways to represent multiplication? We said one of the ways was you could have a number next to another number inside parentheses and there would be no operation symbol in between, and that meant multiplication. Well, the same thing applies for our 3n. There are numbers, a number next to the letter, which represents an unknown number. There are no operation symbols in between, so that means multiplication. So anytime you see a number next to a letter and there's no operations, then the operation is multiplication. Do not forget that. I want to take a step further and talk about 3n. There's terminology that you need to know about the 3 and about the n. It's not just a 3 and it's not just an n. The n, of course, represents your variable. It doesn't have to be an n. It could be an x. Okay, it could be a t, a p. It's just any variable. The number that it represents can vary. It's an unknown number. It can represent several numbers. It could represent the 10th term or the 10th position in the sequence. It could represent the 20th term of the sequence. Okay, it changes, it varies. But that's what the letter's for, letting you know that this is the number that can vary. The 3 is constant. It stays the same. It is called the coefficient. Okay, coefficient to the variable. The way you write it is the coefficient always comes first. You always put the number in front, 3n. You would not write n3, 3n. Okay, on that note, let's go back. We now know our expression is 3n, so we can find the value of the 10th term. Remember, the 10th place is our position, so we substitute the 10 for n, okay, our variable. We do that, and we get 3 times 10. And then you just solve it. 3 times 10 is 30. So if we were to continue our table up here and go to the 10th position, the value of the term would be 30. Please make sure you've gotten all of this in your notes. I want to see in your notes this right here showing us what the change is, showing what the growth is between the terms. I want to see the 3n where you're saying that 3 is the coefficient, n is the variable. And then I want to see finding the 10th term. Okay, and you need to make sure your table is complete, that you've put this 3 in. That's showing that that is the rule. If you need to pause the video, please do so. This is example number 2 for your notes. Please make sure you put the table in your notes. Okay, let's go ahead and find the algebraic expression. Again, the first thing is we need to find the rate of change or the growth between the terms. What's happening from the 2 to 3, the 3 to 4, the 4 to 5? It's increasing by 1. So our growth is 1. It's constant because they each increase by 1. So that means that's what we multiply our variable by. And our variable, if you look up here, it tells us our variable is n. So we're going to multiply by 1. So each position we multiply by our 1. 6 times 1. Uh-oh, that doesn't give us a 2. 7 times 1. That doesn't give us a 2 either. So there's something else that we're going to have to do besides multiplying by 1. So let's take a look. 1 times the 6 is 6. What can we do to 6 that will then give us a 2? Well, we can divide by 3, right? Some of you might say that, divide by 3, and that's true. 6 divided by 3 is 2. But we have to be able to do the same thing to 7. If we divide 7 by 3, will that give us 3? No, it doesn't. So it's not going to be division. So instead, what other operation gives you smaller numbers? Subtraction. So we're going to subtract. So if we multiply our 1 times the 6, we get 6. Subtract what number to get a 2? We subtract 4. Does that work here? 7 minus 4 gives us 3. That works. 8 minus 4 gives us 4. 9 minus 4 gives us 5. So that's what our rule is going to be. We're going to multiply 1 times n and subtract 4. So let's write down our rule. And before we actually write it down, let's start with the 1n. 1 times n. We actually aren't going to go around writing the 1 in front of the n. This coefficient, and I forgot to mention this before in the notes, but this coefficient means how many groups of n. Okay, we're only taking one group of n, so we really don't need to write the 1. Instead, we're just going to write the n. And then what do we do to n? We have to subtract the 4. So our expression, or our rule, is n minus 4. Now that we know our rule, we can find the value of the 10th term by plugging in 10th for n, because it's the 10th position in the sequence. So plug in 10 and you get 10 minus 4, and 10 minus 4 equals 6. So if we were to continue our table and go to the 10th position, which is the next one, it would equal 6, which is true because we're having a constant change of 1. So if we add 1 to 5, 6 would be the next term of the sequence.